So this is our second question in the tutorial. It is regarding amplitude modulation. Amplitude modulation. So before going through this question, we will have a quick recap on here is related to amplitude modulation. So I think you can remember that in amplitude modulation, we are changing carrier signal amplitude, okay, carrier signal amplitude with respect to information signal amplitude, okay? Information signal, message signal amplitude, information signal or message signal amplitude, Okay. So normally this information signal is a low frequency signal. Most probably it may be an audio signal. Okay, so if it is audio signal, it is about 3 kilohertz in 3 kilohertz range, no? So this is a low frequency signal and we called it as baseband signal. This is the baseband signal or message signal. And carrier signal is normally a high frequency signal. High frequency signal, we normally select sinusoidal signal without any phase shift as a carrier signal. Okay, so this is the amplitude modulation. So you can remember that we can write complete amplitude modulated signal. Okay, so this is complete AM signal. Okay, it is varying with time. Okay, so we can write it as 1 plus mu MT. MT is the message signal or baseband signal multiplied by CT. Okay, so CT is a carrier signal. So we can write total modulated signal, amplitude modulated signal in this form. Okay, so here CT is normally a carrier signal. CT is the carrier signal and it is normally a sinusoidal signal. Okay, this kind of sinusoidal signal. So if we write the block diagram, it is just like this. We have a signal, okay, and we have the modulator. Okay, we have the modulator. Then here we have the carrier signal. Carrier signal. This carrier signal should be generated using an oscillator. Okay, crystal oscillator or something. Okay, so this message signal, if it is audio signal, this message signal may be the signal that come out from a microphone. Okay, if someone speak here, okay, so this microphone will convert it to electrical signal and that is the baseband signal or message signal. Okay, so we get AM output. Okay, so if we go further, okay, so this CT is normally a sinusoidal signal. So sometimes this signal is referred normally in some books we can see that the complete amplitude modulated signal is written as with this signal. So AC 1 plus mu MT cos omega CT. Okay, so this one is popular equation, most popular equation, one of most popular equation. So in this course also we can use this signal as the completed AM modulated signal. Okay, so here mu is defined as AM AC. So this AM is amplitude of message signal, amplitude of the message signal, and this AC is amplitude of carrier signal. Okay, carrier signal. So I told you that this mu is related with AM and AC. So this mu already contained the amplitude of this message signal. So this mu already include, okay, this mu already has the amplitude of this message signal. Okay. So I will explain this in further in our example, okay, in our question. So at this time, just keep this in your mind. This mu already has the amplitude component. Okay, so we can expand this signal. Okay, we can expand this signal. So we can write this complete amplitude modulated signal as here AC cos omega CT plus AC mu MT cos omega CT. In this form also we can write this amplitude modulated signal. Okay, so so if we draw the amplitude modulated signal, okay, so if we draw the amplitude modulated signal, okay, so say this is our message signal. So it is like this, okay, like this or something. Okay, we will get a simple signal. Okay, so normally noise signal, voice signal is like this. You can remember that it is like this. The audio signal is just like this. It is a somewhat complex to integrate, complex to interpret, and complex to understand. So we will consider a simple signal. Okay, so this is our message signal. Okay, so you know that normally carrier signal so let's say this is our carrier signal. Okay, let's say this is our carrier signal. So it is a high frequency signal. Okay, normally sinusoidal signal. So we get a cos signal, cosine signal. Cosine signal. So it is like this. This kind of signal, high frequency signal. Okay, this kind of high frequency signal. I'm sorry, I only this kind of signal. Okay, high frequency sinusoidal signal. Okay, so here we have this is a carrier amplitude. No, this is plus and this is minus. Carrier amplitude minus. Okay, so what we are doing, we are changing, okay, we are changing this amplitude, this carrier amplitude according to this signal, okay. So, so if I write, okay, I get this. This part. This part. Okay, say like this, okay. So this is the carrier signal, okay. So we know that the amplitude, in amplitude modulation, we are changing this carrier amplitude, according to this signal amplitude, the information signal amplitude, okay. So let's say this amplitude is AM, okay, AM, amplitude of modulating signal, and this amplitude is AM. Say this is AM, and say this is AM1, okay. So for simplicity, we will consider this. This can be different. This amplitude level can be different, but for simplicity, we will consider this as same. So this AM, and here this minimum amplitude also AM. Okay, we will consider like this. Okay, for our simplicity. Okay, so if I mark other 2 points here and here. Okay, so this is AM, from this AC to AM. So this one will be AC plus AM. Okay, so this amplitude will be AC minus AM. Okay, like this. Okay, so you can see that if we draw the amplitude in carrier frequency with respect to this message signal, so it will look like this. Okay, so here the starting point, it is starting from 0, here 0. Okay, so now this is the reference 0. Okay, so this is the reference 0 for the envelope. Okay, for writing the envelope, for drawing the envelope. Okay, so here it is. So if I mark this 2 point also, this one, this, like this. Okay, so we will get like this. Here we have the maximum, then it is come to 0 again, 0, then it is go to minus AM. So at this point it is going to minus 0, no? This point, okay, this point, and this point, okay. So here, so it is come to minus 0, okay, then it is again going to 0, and it is like this, it will go like this. Okay, so we get this kind of signal, and you know that here the below parts also will get the same pattern. Okay, we'll get the same pattern. So here also, if I mark this, it is, and mark this one. Okay, so this point is minus AC minus AM. Okay, so this point is minus AC plus AM. Okay, Okay, so we have so here it is starting from here. Okay, and it goes like this. Okay, and then it come to the uh, 0 level. Okay, then it come to the minus AM level, then again it's go to the 0, and it is go like this. Okay, so so this is the amplitude modulated signal. Okay, so this is we called as a envelope. Okay, this blue color cover is considered known as envelope of amplitude signal. Okay, so so if I consider that equation, here I will write it again. So here complete AM signal, modulated signal is equal to AC 1 plus mu MT cos omega CT. Okay, so so you can see that this signal, this point is the maximum of this signal, no? So it is the maximum level of this signal, this amplitude modulated signal. Okay, so okay, so if we consider the envelope, so you can remember that we can consider the envelope as 1 plus mu MT. Okay, so this is the envelope of the signal. So it is a time varying function, that is the amplitude of the modulated signal. Okay, so amplitude of the modulated signal also time varying signal, because we are changing the amplitude. Okay, so that amplitude function or envelope we can write this as, so that is the amplitude of this complete signal. Okay, so complete signal, we remove this cos part. Okay, then we get this part, this is the amplitude. Okay, this is changing according to this MT. Okay, so you can see that this MT means the amplitude. Okay, that is this AC is changing according to this MT amplitude. Okay, so this MT is a it may be a voltage varying signal with respect to time. Okay, so that is the voltage is the amplitude. So for this signal, amplitude is changing with respect to t. Okay, amplitude is changing with respect to t. So because of this part changing, this whole equation will be changed, no, changing according to time. So this is a time function. Okay, so what is the maximum amplitude of the modulated signal? So if we get the maximum amplitude of total modulated signal, so let's take as a max. Okay, so this is the maximum amplitude of the envelope. In another word, we can say that this is the maximum amplitude of this envelope. So here this point. Okay, this point is the maximum. Okay, so what is the answer you get? Okay, so here you have A, C class. So here I told you that this mu already has the amplitude of this MT. Okay, okay, so here already mu has that amplitude, the maximum amplitude. Okay, so here the maximum amplitude is mu. Okay, when this equal to mu, we get the A max. Then this is change. Okay, from mu to minus mu. Okay, so this, if we consider this part, okay, when MT is changing, the mu also changing from mu to minus mu. Okay, so this is the maximum signal maximum amplitude of the envelope. Okay, so what is the minimum amplitude of envelope? What is the minimum amplitude? Minimum amplitude is this point. This is the minimum amplitude point. Okay, what is the This is the minimum amplitude point. Okay, this point. So what is the amplitude? Amplitude minimum for total modulated signal. It is AC plus AC1 minus mu. So this is the minimum amplitude level. Okay, so this one is the A max. Sorry, this point is the A max, maximum amplitude of the envelope. This is the maximum amplitude of the envelope, A max. Okay, and this point is the minimum amplitude of the envelope. It is A min. Okay, so this point is the A min. Okay, so this is the minimum and this is the maximum. So we can get it like this: AC plus 1 plus mu, AC plus 1 minus mu. Okay, so in this way also we can get it. Okay, so you can see that. Okay, this mu is equal to AM by AC. We already uh, defined this mu. Okay, we already defined this mu. So mu is equal to AM by AC. So if you apply this AM by AC here, you will get A max as AM plus AC. Okay, I will write it, change in the position, AC plus AM. Okay, so if you apply here AM by AC, so if you get, you can write this AC plus AM divided by AC, then AC cancel out, and you will get AC plus AM as the maximum signal. Okay, and for the minimum signal, in same wise, so here it is AM by AC, so AC minus AM divided by AC, then AC cancel out, you will get AC minus AM. Okay, so this is the minimum amplitude. Okay, so mu also can be defined as AM by AC, and also we can define it as, okay, using this equation, A max minus A min. Okay, here if you subtract A max from A min, what happened? A max from A min, then AC cancelled out, you will get 2 AM. So here you will get 2 AM. Then if you add AC max plus A min, then AM cancel out, you will get 2 AC. Okay, so if you get A max plus A min, you will get 2 AC. Here this is 2 AC, and here you will get 2 AM. Okay, then 2 cancelled out, again you will get AM by AC, that is mu. Okay, AM by AC. So in this way also we can define the mu. Okay, so it is better to remember these things. Actually, no need to remember everything. If you can see the, if you can understand the pattern, okay, how this happened, then automatically you can derive any equation within here. But this one should be, you should keep it in remember. Okay, so another important thing, okay, another important thing is that this mu. Okay, so this mu, AM by AC. Okay, so this is defined as modulation index. Okay, so this is defined as modulation index of AM signal. Okay, if we get this mu as a percentage, it is called modulation percentage. Modulation percentage. Okay, percentage. So we will see this also. Okay, we will see this also. So you can see that. Okay, okay, I will get this diagram again. Okay, so for example, think that Okay, here now this AM, okay, this AM is less than AC, no? So this AM is less than AC. Okay, then uh, then A mean, if we consider this minimum point, okay, this is AC minus AM, so you will get the plus value here. Okay, so you will get the plus value. So you will get the envelope like this. Okay, so you will get the envelope like this. So what happened that at that time AM should be less than AC. Okay, so here mu is equal to AM AC. Okay, then if AM is less than AC, okay, so you will get this kind of envelope. Okay, so this is the correct envelope actually. So at that time, what is the what is this mu value? Okay, mu value. Here the AM is less than AC. Okay, this AM is less than AC. So this mu is less than 1. No, so this mu is less than 1, and also it should be greater than 0. Okay, so this mu will be less than 1. Okay, so if you get AM and if you get AC as 2 AM, the double of amplitude, I will get some example. So you get AM as 2 volt. Okay, so you will carry a signal amplitude as 4 volt. Okay, so what is the mu? Mu is 2 by 4, that is 0.5. Okay, so example here, I get the example. Okay, that is 0.5. So if we get the modulation percentage, it is 50. Okay, so here if we get AM as 2 volt and AC as 4 volt, modulation percentage is 50%. 50 modulation percentage. Okay, so at that time we will get this kind of envelope. Okay, so if you get this AC as 1 and AM as 1 volt and AC as 4 volt, then you will get at that time mu as 1 by 4, that means 0.25. Okay, so what is the percentage? Modulation percentage, it is 25%. At that time also you will get this kind of signal. Okay, so say that you get AM equal to AC. Okay, at that time what is the mu value? Mu is equal to 1, so percentage is 100. No? It is 100%. Okay, so what happened in 100? Okay, so you can see that. Okay, so you can see that if this AC and AM is equal, if this AC and AM is equal, if AC minus AM, it will come to 0. So this will goes to 0 like this. Okay, and this line will also going to 0 like this. Okay, and we get the like this. So you can see that if AM is equal to AC, that is mu is equal to 1, it touch the T line, 0 line. Okay, it touch the timeline, time axis. Okay, so it touch the time axis. So you can see that at 100% modulation, okay, the envelope of the modulated signal touch the T axis. Okay, T axis. Okay, at that time also we can correctly get the envelope somehow. Okay, but this is not guaranteed. Okay, so so for the AM modulation, always this mu should be less than 1. That is the guaranteed value for this mu. That means we have to take the carrier amplitude. Okay, carrier amplitude greater than, okay, greater than, carrier amplitude should be greater than the modulating signal, information message signal amplitude. Okay, so mu should always should be less than 1. This is the guaranteed value for mu. Okay, so this mu is very important one. Okay, so what happened? This AM is greater than AC. For example, you get AM as 4 volt, AC as 2 volt. What happened? What is the mu value? Mu value is 2. If we get the percentage, it is 200%. Okay, so this is called overmodulation. Okay, this scenario is called overmodulation. If we get AM is greater than AC, it is called overmodulation. And let's see what happened there. Okay, so you can see that here it comes if this AC is greater than AC is less than AM. So AC minus AM is in minus side, no? So this will go and cross the line. This will go and cross the line like this. And here also come and cross this line like this. Okay. Then it is goes like this. Okay. So you can see that some crossing is there. So at this cross point, always you can note that carrier signal phase is shifting, changing. Okay, carrier phase is changing. Okay, so in next session I will show this. Okay, in the second session I will show this in MATLAB program. Okay, so just get this idea. Okay, so that is regarding the AM signal, time domain signal. Okay, so so electronically we can, in electronic, okay, in electronic we can implement this. Okay, we can implement this. Okay, there are many methods, AM modulator, there are many type of AM modulator. Okay, but I think most simple one is the transistor AM modulator. Transistor AM modulator. Transistor AM modulator. Okay, so using a transistor we can implement the AM modulator. Actually that is the so the most popular transistor modulator is the common emitter amplifier. Okay, so common emitter amplifier. So internet also you can see this. Okay, and I think there are many YouTube's videos related to this transistor modulator with common emitter amplifier. Okay, so you can refer. There are many tutorial available in YouTube and internet. You can refer if you want to get more knowledge. Okay, so we can achieve this AM modulation through this simple common emitter amplifier. Okay, so I think you can remember the common emitter amplifier. In our lab we will try to do this. Okay, in our lab we will try to do this. So if we have a transistor like this, okay, transistor like this, so it is NPN transistor, no? Here I go NPN transistor. Okay, so this should be a base and this should be a collector and this should be a emitter, no? This is collector, this is base and emitter. So common emitter means we have to ground the emitter. Okay, we have to ground the emitter. Okay, sometimes we are using a capacitor here. Okay, and we get the output from collector. Okay, so base is the input, no? So we have to give the biasing. Okay, we have to give the biasing. Here we have to use the trans resistor, and here we are using that potential divider. Okay, like this. Okay, so normally this is the common emitter amplifier. Okay, so we can use the capacitor also here. So this is the V in and this is the V out. Okay, for the amplifier. So if we define this gain of the amplifier as A, okay, we get V out as A in, okay. So this is normally a amplifier, okay, common emitter amplifier. So if we put the carrier signal here, okay, so using oscillator, we put the carrier signal here. Okay, so we give the carrier signal to this V in P carrier signal. So this is the high frequency signal we are giving. Okay, and if you connect, okay, if you connect the audio signal or the modulating signal here, okay, modulating signal here, okay, so this is the carrier signal, the high frequency signal, and this is the audio signal, the low frequency signal. If we put it here, okay, so this signal, this audio signal, okay, you can see that this audio voltage, so here signal will give a voltage, okay, so this audio signal will give a voltage. Let's say it is Vm, modulating voltage, okay. According to this voltage value, this transistor biasing is changing, okay. So because of that, this A also change, okay. So this A gain is changing according to this audio signal, okay, MT audio signal. With MT, this A is changing, the gain is changing. So we get V out, V in, A by V in, okay. So V in is a carrier signal. So this carrier signal, okay, is varying, carrier signal, the output is varying, amplitude will vary according to this A, and this A is varying according to this information signal. So you will get the AM output, okay. So sometime I just explain it as I can remember it, okay. So sometime some correction may be there, okay. So anyway, you can refer internet. I just want to give you idea how we can construct a modulator, okay. So using a transistor, we can do this. The most popular, one of most popular implementation is using a common emitter amplifier configuration to implement an AM modulator. So this is the general, okay, the approximate description of how it works, but maybe not 100% accurate, okay. For more details and accurate details, if need, please refer the internet or YouTube, okay. So this is the, so we discuss here the waveform representation, that is time domain representation, and we also discuss how we can implement amplitude modulator, okay. So next we will see the frequency frequency domain representation of this amplitude waveform, okay. So we will see it